In example 2, we are going to write exponential growth models. Letter A says a savings certificate of $1,000 pays 6.5% annual interest compounded yearly. What is the balance when the certificate matures after 5 years? So we are looking at something that's going up, which indicates exponential growth. So I'm going to move this down so we can see our exponential growth model. And we need to come up with our variables. So the first variable we're looking at is variable C. And C represents the initial amount. So how much should we start with in the beginning? Well, in this problem, it says we have a savings certificate of $1,000, and that's what we're starting with. We're starting with that $1,000, so that's C. Then we need our R, and R is the growth rate, a percent as a decimal. So our growth rate, this paying 6.5% interest compounded yearly, so 6.5%. Now we have to change that 6.5% to a decimal. So we take the 6.5, and because percent is out of 100, we are basically dividing by 100. And the short way to divide by 100 is just moving that decimal places, or that decimal point 2 places to the left. And so we fill in that 0 there. So our R value is 0.065 as a decimal. Then we need to know what T is. And it says, what is the balance when the certificate matures after 5 years? So our time period we're talking about is years, and we're looking at 5 years to have gone by. And then Y, what is the amount after that time period is passed? Well, that's what we're looking for. That's our unknown. So now all we have to do is plug everything into our equation. And we get Y equals 1,000 times 1 plus 0.065 raised to the 5th power. We can add this together first to simplify it. We get 1,000 times 1.065 raised to the 5th power. And then I want you to type that into your calculator and make sure you're typing things into your calculator the right way. So go ahead, pause the video for a second, plug that in, and see what you get. If you plugged it into your calculator correctly, we're talking about money here, so we should be labeling our answer with dollars. And we have $1,370.09. So check your rounding, make sure you rounded everything appropriately. If you have questions on letter A, let me know. Otherwise, let's go ahead to letter B. Letter B says a newly hatched channel catfish typically weighs about 0.3 grams. Its growth is approximately exponential, increasing by about 10% each day. Write a model for the weight. Let X represent the number of days, and let Y represent the weight of the catfish. So, in terms of our function on the top, we have to start by labeling what we have. So we need our initial amount, which is C. So what are we starting with our catfish? And that catfish weighs 0.3 grams to begin with. So our C value is 0.3. Then we're looking for a rate. How much is this changing, going up by? Remember, it's growth, it's growing, so it's exponential growth, and our rate is 10%. And 10% as a decimal, remember, divide that by 100 is 0.1. And then we need something for our time. And in this case, since we are just writing a model is going to have 2 variables in the answer. And what we want to do is we want X to represent the number of days. So instead of using T, we are going to be using X as our time frame. And then Y is still going to represent the end weight of that catfish. So we have Y equals 0.3 times 1 plus 0.1 raised to the X. And then we're going to always simplify what we have in here. So let's add those together to get the most simplified equation. And that's going to be Y equals 0.3 times 1.1 to the X. That's our model. And the second part says, how much will the catfish weigh in 25 days? Well, here we know that our X value is equal to 25, and so we're just going to plug that into our equation that we got right here. So we have Y equals 0.3 times 1.1 raised to the 25. And what I want you to do is I want you to plug that in. So again, plug that into your calculator, hit pause if you need to. And you should end up, if you plugged it in correctly, at 3.3, and we're talking about grams in terms of our weight, so 3.3 grams for our final answer. We have one more that we're going to do together, that's letter C. And letter C says, an experiment started with 100 bacteria. They double in number every hour. Write a model for the number of bacteria. So remember, that model is going to have two variables. You're going to have your y, and you're going to have your x or your t. What's different between letter C is that we're doubling. So we actually have a growth factor rather than a growth rate. So this doubling right here, this is a growth factor. So we know our initial amount. We know C is equal to 100. And then instead of knowing R, we actually know the growth factor, so we know 1 plus R is 2. If it's doubling, it's 2, tripling would be 3, quadrupling would be 4, and so forth. And then we don't need our time right now because we want that as a variable in our problem. So we can write this as y equals 100 times 2 raised to the t. Again, a little different than the previous ones because we have that growth factor instead of the growth rate. And that just goes in as a 2 in that spot, raised to that t. Anytime you have a model, you have a variable here, and you should have a variable on the right. Number 2 says find the number of bacteria after 8 hours. So now what we're going to do is we're going to plug in 8 for t. So we know t is equal to 8, and we have y equals 100 times 2 to the 8th. Plug that in on your own first, and then double check that what I have is the same. And if you plug that in correctly, you should get 25,600 bacteria. If you have questions on plugging it in or where the numbers are coming from, please let me know. Otherwise, I'd like you to do the try this. When you're done with the try this, so pause it now. When you're done, go ahead and unpause it and check your answer. If you did the try this correctly, you should get a model that says y equals 220,000 times 1.021 raised to the t. If you have questions, let me know. Otherwise, you can move on to example 2.